Hey, science guys, it's Monday. We're going to start a lesson on forces this week. So you got a few pages, 254 to 257 for your Monday work. Just going to go over a couple things real quick. I don't think this will be too long a video, but we're going to do a few examples of some forces. So last week we talked about motion, things moving around. We talked about calculating speed. We talked about velocity and acceleration and all those sorts of things. Now we're going to talk about the things that cause movement or cause motion, which are forces. Just like motion happens all around us, forces happen all the time. We don't even think about using forces, but if we look at a few definitions here, we'll see some examples and talk about how forces are all around us all the time. One thing we've got here for our force definition, our first couple pages, force is any push or pull. Real simple definition, just like motion is a change in position. Force, real simple definition, changes in motion have one thing in common is that they require a force which is a push or pull. Real simple definition there, okay? Make sure we have that there. A force is a push or pull. When we push on things, when we pull on things, we're using force. Even when we walk around, we push against the ground, and that helps us move. Let's think about some of the examples we've got here. It says draw an arrow that shows the direction of the forces applied to the cart by the horse. So if this cart is being pulled by the horse, right? The horse is pulling on it. That motion would happen in which direction? Well, that's going to be, it's a good color here. That's going to be happening in this direction, right? The force would go this way, okay? The horse pushes on the ground and moves its muscles and pulls that cart in this direction, pulling on it as it goes, okay? So there's that to start us off. We have a few other examples here, like it says when the rowers pull back on the oars push against the water, and that makes the boat go. The water pushes back against the oars, and this force causes the boat to move. That's kind of the big one there, too, okay? Other things, we'll look at a couple of examples having to do with basketball. But when we bounce a basketball, hits the floor, the force of the floor makes the ball stop, bounces back up. The person pushes down. When you're dribbling a basketball, you push down on the ball, down, 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 bounce, bounce, bounce. You're using force in your hand to push, and then it bounces back up, okay? So that's kind of just the real quick basics of what forces are, just any push or pull. Again, whenever we move, we use forces. Our muscles have forces. We use our muscles to push or pull on things, and even if it's our own body, to get ourselves to move and do the things we have to do every day. So again, sometimes this stuff is stuff we don't even think about, but we do it all the time. You're right now probably clicking your mouse or pushing on your pencil to make notes in your notebook or in your textbook, and that is using forces. Okay, so again, this is a neat part of science where it's like these everyday things we don't usually think about. We can slow down and study if we really think about them and learn some pretty neat stuff. Okay, then the next couple pages for today talk about two common forces. One we've talked about quite a bit with our space unit when we talked about gravity. So gravity is a big time force that's around us all the time. Again, these two forces we're going to talk about are ones that are acting on us all the time. Gravity is always pulling us down toward the earth. That's why we don't float away like our space guys we see, like the astronauts in the International Space Station, are just kind of more floating around because they don't have that big object of Earth pulling down on them. Okay, so skydivers, when they're doing their skydiving, falling down toward the Earth, the petals on this flower fall down toward the Earth because gravity is pulling. So any push or pull, gravity pulls things toward it, pulls objects together. That's a big one, okay? The other one is friction. Friction is a word you may have heard, but we haven't really talked about it all this year so far, so let's talk about that. We say it's easier to ride your bike on a smooth road or a muddy trail. Why? Well, it'd be easier on a smooth trail. We're going to talk about more or less friction, but let's talk about what friction is. Friction is a force that opposes motion, and we'll talk about that a little bit down the road. It says friction acts between two objects that are touching, such as bike tires on the road. Friction can also exist between air and a moving object. So even like when you're throwing a ball through the air, the little air particles are rubbing against things. So friction is like a rubbing force. It's called a contact force. Two objects that are touching are in contact. So sometimes we want to increase friction, and sometimes we want to decrease friction. Okay, it depends on how we're using it, but we use it all the time. When you walk across the floor at your house, if you don't have socks on, say you're like in the kitchen on the tile or the hardwood, your feet kind of stick a little bit. You don't slip and slide. If you put on socks, I'm sure we've all done that. My son and daughter do it all the time, where they have their socks on, they slide across. When we do that, there's less friction. So things that have less friction are going to be like more slippery, not as sticky, I guess you can say. Now, if we play or if we're walking on our carpet, we don't really have to worry about slipping and falling because there's like more contact there. There's more rubbing, there's more touching, there's more friction. So more friction means things kind of stick a little better. Less friction means things are a little slippery. So things like ice reduce friction and cause you to slip. If you ever slip in a puddle or something or on a wet floor, that's because there's less friction. Usually we take advantage of friction when we just walk around and there's our shoes touching the ground have friction that keeps us from just slipping and falling. If there was no friction, we just slip and fall all over the place. But luckily, friction is something we use in our daily lives that allows us to just live our normal lives. Again, we don't really think about it too often, but if we slow down and think about it, we can identify that these things are around us all the time. Okay, I'm going to look at this little section here with these 3 examples and kind of go through that with you. And then we're going to look at a couple extra examples too, okay, to help us better understand friction. So here it says in the pictures on this page, circle the places where there is friction between 2 objects. And then the small boxes write I and C if the object is designed to increase friction, meaning create more rubbing, or if it's designed to decrease friction, we'll put DEC, or I'll just put D, okay? So in our first example, we see sandpaper rubbing on wood to smooth out the wood. Now, where the friction exists is where the contact is. So if I just, let's maybe say we'll do that in green where the friction happens. The friction happens between the objects here. When we use sandpaper, we rub on the wood or whatever else it is. I actually just used a nail file this morning to cut my nails, and you rub it to kind of smooth out the nails, smooth out the rough edges. What we're trying to do there is that going to be to have us have more or less friction? It's going to be to have more rubbing to help smooth things out. So we're going to say this, I'm going to put an I here for increase friction, okay? Increase, make it more. We want to increase how much rubbing there is, okay? If we look at the example of an air hockey table, an air hockey table blows air upward. This layer of air reduces the surface friction so the pieces move quickly. Well, where the friction happens here is maybe on the puck or on the, whatever you call that thing, the mallet, the thing you use to hit it. Mostly on the puck, though. The goal is to get that puck to slide. Now, if you ever used an air hockey table that didn't have the air blowing up, it doesn't slide as well, and that's not very fun. But when you turn that on and the air puffs up out of it, that actually decreases the friction. It's less rubbing. Less rubbing means it can more smoothly glide, just like ice skating on ice. So I'm going to put a D here for decreasing how much friction is. The goal is to have less friction, and that makes, in this case, a fun game to play with the air hockey, because then that puck can slide all over the table and make it for a fun game, kind of like being on ice. Again, ice has less friction, more slippage, okay? The less friction there is, the more slippery the objects can be. The more friction is, the rougher or the less sliding there can be, okay? So that's kind of the idea here. Now our last one, it says the tires on this bike are designed to keep the rider from slipping. So in this case, we don't want a lot of friction, okay? Or sorry, we don't want a lot of slippage. We do want friction. So in this case, we'd have the tires on the ground. Now, if you've ever seen a mountain bike tires, they have like those spikes and bumps and things, and that's designed to increase the friction. So the goal with mountain biking is to have good grip so you don't slip and slide through the rocks and the dirt. And so in this case, we want more friction to happen, which causes less slippage, more firm grip, okay? So that's kind of the things we can look at there. Sandpaper, we want more friction. Ice skating or you playing air hockey, we want less friction, so it's easier to glide. When things are able to glide smoothly, there's less friction. And then also in this case, we have the mountain bike, we want to increase friction. So sometimes we want more, sometimes we want less. It just depends on what we're trying to do, but it all involves us understanding how friction works, okay? So I've got a couple other examples here. Great example of friction I always use in the classroom is just rubbing your hands together. If you're ever cold on a winter day especially, you might rub your hands together real quick. When you're doing that, you're causing friction to happen. What happens as a result of that? If you try it right now, what do you notice with your hands? What you notice is it gets warmer. Friction produces heat as well. So when we do that, when we have that rubbing going on, that's why we rub our hands together in the wintertime when we're cold, it creates a little bit of heat. And so that's a good example of causing more friction, okay? Let's talk about this example. If we have our A and B here, we have one person skiing down a snowy slope, and one person just maybe pretending to do so on a hill. Let's talk about which one of these would have more or less friction. There's friction between the two because there is touching happening, but the one that's going to be slipping or sliding a little easier is going to be the one that has less friction, okay? So out of A or B, which one of these is going to be less friction? Check for yourself now, which one will have more, okay? So what do we think? Let's talk about it. I'll change to red so we can see. In this case, when we want to slide more, so we want that to have less friction. So I'm going to put less friction over here for A, okay? And then unfortunately, again, this kid might just be pretending he's skiing, but he'd probably just kind of be standing on that hill because it's grassy and he's got his shoes on. And so this is going to be more friction, okay? So more friction means less slipping. Less friction means more slipping, more smooth, and that's what makes it fun to ski or skate because we have less friction, so we glide right across, okay? Another example here is if we use a water slide. If you've ever gone to like a beach water park or a Kings Island water park and you go on the water slide, you zip right down there because that water helps to decrease the friction. So this is going to have less friction than a regular slide. If we went down just to, sometimes if your leg gets stuck on a slide, like where your skin is, if you're wearing shorts, you get kind of stuck because there's more friction. Or if you have like gym shorts on when you go down a slide, that touching is not as tight, not as firm as if we had just our skin. Sometimes, again, your skin gets stuck on the slide, and that's not very fun because you don't slide down it. But we can decrease the friction, which causes more smoothness, more gliding, and so that's why water park water slides are really fun because that water helps to reduce the friction. Okay, a couple other examples having to do with sports. If you play soccer, you probably wear cleats, and those cleats help you increase the friction so you don't slip around like when you're doing your moves and running around. If you've ever maybe forgotten your soccer cleats and you went out and just ran around in the grass like in smooth basketball shoes, you might notice you don't have as good a grip and you kind of slip and slide a little bit, not like you slide across ice, but you maybe don't get as good of a grip. So the grip here, the increasing the touching with the surface of the grass is kind of the goal here with having those particular cleats that grip into the grass and then allows you to stop and move and go. And so when we have more friction, that allows us to do those things on the soccer field or in this sport. I'm actually going to use an example here with Michael Jordan here in a second, show you a famous shot. If you've been watching the Last Dance documentary, it's pretty much the only sports we've had going on lately, right? Unfortunately, the NBA season's not happening right now. But I've had a lot of fun with my son watching the Last Dance documentary, which is on ESPN about Michael Jordan and his career. And I know a lot of people say that, you know, LeBron's better than Michael Jordan, whatever. Hopefully, if you're watching this, you guys, especially, I'm sure some of you are, you're seeing how great and amazing Michael Jordan was. One of the shots actually I think in the last couple episodes they showed was a famous one. It's probably his most famous shot. It didn't win an NBA championship, but it's definitely one of his most famous clutch shots. I'm actually going to show you that now. This was against the Cleveland Cavaliers in the NBA Eastern Conference playoffs in 1989. If you don't care one lick about basketball, that's cool, but I am going to show you a couple little things real quick with where we can see friction happening with this stuff. This is one of Michael Jordan's most famous plays. I'm going to play this video, and we're going to kind of look and stop and see just a quick few things where there's more friction. In this case, basketball shoes. If you guys have nice new basketball shoes, you notice they stick to the court, and you can juke and jive real quick and make good cuts and things. And if you have worn out shoes, you might notice you slip and slide, and it's not as easy to make your moves on the basketball court. Michael Jordan wanted lots of friction on his shoes so he could make all the moves he wanted to make his awesome play. So let's watch this video here as we play. Hopefully it'll play. There we go. I'm going to play the video here, and then we'll see a replay of where we can look at the friction. So here's moving around. Here's Michael Jordan. He's going to get the ball. He's going to move. He's going to make cuts. He's going to use friction. Gravity pulls the ball down, makes it into the basket. Big famous play. Okay. I'm going to go ahead and show in the replay here. You're going to notice I'll pause a few parts where he puts his foot down and goes another direction. That's an increase in friction. Okay, so again, we're just having fun here, highlighting how friction we can take advantage of friction when we play sports and things. So watch here. I know it's not a great video. It's from many years ago when I was 4 years old when this happened. So you can tell that's a long time ago. But as we go here, he's moving. Here he sticks his foot down to the ground. He changes direction. If his foot slipped because of sweat or water being there, there'd be less friction, and this play wouldn't have happened. But he takes advantage of the amount of friction he's got here and pushes back this direction. Now we see here he puts his foot down here. He's trying to get open, trying to get off his man here so he can get the ball and make his cool shot. Now he puts his foot down. Again, if there was water on the court here, his foot would have slipped. He'd have fell on his face and he'd look like a moron. But instead, he's the greatest basketball player ever because he's able to use friction here. Okay, so you're going to see he changes his position, puts his foot down. His foot doesn't slip because there's lots of friction between the court and his shoe. And then he can push off, go and get open. Here he catches the ball. Again, it's not a great view, but he's got his leg out this way. So this leg is stopping all his motion, and he's going in an opposite direction. He's going to go back this way by pushing off again. Friction stops his foot. His foot doesn't slide out. And then he goes here, stops, pops, hits the shot, gravity pulls it down. Boom. Greatest.